An object of mass m is initially at rest and free to move without friction in any direction in the xy plane. A constant net force of magnitude F directed in the positive x direction acts on the object for 1 second. Immediately thereafter, a constant net force of the same magnitude F directed in the positive y direction acts on the object for 1 second. After this, no force acts on the object. Which of the following graphs best represents the kinetic energy K of the object as a function of time? Here, what is happening? The force is applied on an object for 1 second in the positive x direction and later along the y direction for 1 more second. That's it. And they have drawn the graph between the kinetic energy and the time. This is the kinetic energy versus time graph. How it will be? First, let us see what is the direction of the velocity. As you know, as the force acts on an object, the object gets accelerated. Object is getting accelerated means the velocity is increasing. So for the first 1 second, the velocity is increasing along the x direction. And next 1 second, the velocity is increasing along the y direction. So x direction, initially it is only along the x direction, no other direction. Obviously, it is just a straight line along this is the Vx. Okay, for the first second. Velocity is continuously increasing. As the time increases, velocity increases. Now, what is happening in the next second? The velocity is increasing along the y direction. So we have to take the resultant of both x component and y component. Agree? Initially, because the force is acting on an object, the object's acceleration increases because F is equal to ma. Acceleration is increasing means the object has some acceleration. So the object has acceleration means its velocity is increasing. That is the basic principle here. So this is along the x direction. Next, what is happening along the y direction? Same thing is happening along the y direction also. But when it is happening along the y direction, it has already x component of velocity. Am I right? So you have to take the resultant of these two. So this is the resultant of the both x component and y component velocities after 1 second. Okay. Now, coming to the next point, how the kinetic energy is related to velocity. Kinetic energy is equal to half mv square. So as the velocity increases with respect to time, it is increasing in a quadratic way. Am I right? When it is increasing in a quadratic way, the graph should be, the equation of the graph should be y is equal to x square. Am I right? So what will be the graph, nature of the graph in a parabola opening upwards? This is the graph for this equation. Am I right? This is the x component and this is the y component, and the graph will be like this as y is equal to x square means. So then what about the next second? This is for the first 1 second. Then for the next second, again the same way, but it is a bit steeper because it has both x component and y component. Resultant will be a bit more. So it will be again the same way, but it's a little bit steeper. And then next it will be straight line. So if you find this kind of graph, then that will be the answer for the question. So where it is, this kind of thing. Here, the B is the answer for this question. That's it. Hope this helps. Thank you. Bye-bye.